Total cost function. Anyone would like to tell us what is the total cost function equal to? In words. In words is fine.
The variable cost.
Yes.
The fixed cost.
Yes. Variable cost does not depend on X, but the fixed cost does not depend on X, but the variable cost depends on X. That's why I put X. This is just a number, but this one depends on the number of units. Awesome. Revenue function is price times X. A total profit function, what did we say the profit function equals to?
Revenue
Yes?
function minus the cost function.
Excellent. Please remember, there are two pieces in the cost function. If you only subtract the variable, but you are adding the fixed instead of subtracting, that will be incorrect. So to be exact, we have revenue minus the variable costs minus the fixed costs. There are not two minuses. The reason why I write a minus, that's my habit. You don't have to do this, but if I don't write something, how will I know that something follows if I don't put a symbol here? So it follows, so that's why there is a minus, not two minuses that make a plus, but it only says there is something that follows. So please make a note of this. When you subtract the cost function, the total cost function, you must subtract the variable and you must subtract the fixed. Not subtract just one or the other. Okay. What is the break-even point? How do we obtain it? The break-even point.
Profit function equals 0.
Exactly. The profit function equals 0, or if you don't like this, which is the same, what is the other option?
R of X equals CRX.
Yes. Revenue equals total cost. Awesome. What about the equilibrium point? How do we get the equilibrium point?
It's where everybody's happy.
Yes. When everybody's happy, when the demand function equals the supply function. The demand function equals the supply function. And remember, the equilibrium point is a point. So it has to have an X and it has to have a Y. The Y value is any of these two because they are the same. They will be the same. Okay? So an X and a Y. What is the limit operator? So basically we have three if you want. LIM f of X as X approaches A. LIM of f of X as X approaches A from the left. And limit SF, I never say LIM. Limit f of X as X approaches A from the right. So there are three different things. This one is from either side. This one is only from the left with numbers smaller than A. This one is only from the right with numbers larger than A. Okay, I'm going to share my screen to look at our first question here. I can't see you. Where are you? Here you are. Okay, I'm sharing my screen. And I think that I just opened it. Here it is. I think it's this one. Is this the one or a different one?
Yes, that's it.
Okay, perfect. So what I wanted to explain is this inversely proportional. Okay, that's the key word or keywords here first. Okay. So I have to come back to that. Okay, so that's my page 2. So relationships between I told you sometimes I swallow words when I write uppercase letters. Don't let me do that. Relationships between two variables. Direct, inverse. The direct y equals k times x. So here's a direct. As x increases, y increases. Okay, so that's direct. K is a constant. We call it constant of proportionality. Okay, what about the other one? Inverse. The inverse is y equals k over x. And how will this look like? Well, something like this. Why? Because as you see, as x increases, y decreases. The same thing, it's a constant of proportionality. So when you hear the two variables are related by an inverse relationship, then you have to have in mind this equation. If it's direct, then this will pop up in your mind. So now we can go back and read the question. According to Zipf's law, find the number of cities n, uppercase N, with a population greater than S is inversely proportional to S. So because it's inversely proportional, I have to have this in mind. N equals k over x. Here, y is inversely proportional with x. Here, n is inversely proportional with s. So this is the relationship we have to use. Then, what else they want? In 2008, there were 52 U.S. cities with a population greater than 350. So 2008, I'm just copying. 52. Good. Estimate the number of U.S. cities with population between 350 and 500. Between 250 and 650,000. Can we do just one of these? Oh, but I see you already obtained that answer for the second one. Do you still need?
I was just playing around with it. I'm still not really sure how to do it.
Oh, okay. Good. So, and they say in 2008, there were 52, okay? Greater than 350. Estimate the number of. Okay. Good. So, do they give us anything else in here? According to the number of U.S. cities with the population between 300 and 400, that's what they want. They want between 300,000. I didn't copy that part. What was it? 300 and 400, yes. Okay, so keeping in mind that this is the relationship, to determine the constant, because that's the key here, we want to determine the constant of proportionality. So we will substitute, first of all, and replace S, right? So it says substitute 300, right? So we will substitute 300,000 for S, and population larger than 300,000. Okay. And in 2008, so that's the number of cities greater than S. It's inversely with S. So they had 52. That's our 52 equals K divided by That's it, greater than 300,000 divided by 300,000. So that's the S. In order to determine K, so then K, we have to cross multiply because this is 52 over 1. So K times 1 equals 52 times this. Okay, I don't need a calculator for this. This is 6 and 15. And 1, 2, 1, 2, 3. Okay. Now, when we replace 400,000, 52 equals K over 400,000. That's just the difference. Cities with a population between 300 and 400,000. Inversely proportional, 52. Cities with a population greater than 300,000. So that's our K. Estimate the number of US cities with a population between 300 and 400,000. So $52 equals K, which is 15,600,000 divided by S. They're not giving us inversely proportional. What was his law? That's all he says. Let me share my screen again. So 52, greater than 350. Okay, so I have to find K with 350,000. Sorry about that. So 52 equals K divided by 350. Not with 300,000. And then what we need to do after we determine, so K has to be determined. I didn't write the 350,000 here. That's what the problem was. So in 2008, 52 cities had more than 350,000. So this is how I have to find K. I omitted to copy the 350,000. That's my, so sorry about that. I have to cross this out, and I have to cross this out, and I have to cross this out because I have to use 350. Okay, so K equals 52 times this. Oh, what is my calculator doing? So 52 times 350. Okay, so K is 182. No, it's 18,200,000. Okay. So then the relationship, now we have the relationship, which is N equals 18,200,000 divided by S. Again, in 2008, 52 had more than 350,000. N is 52, S is 350,000. Now, they are asking us to estimate, not an exact number, but to estimate what, how many cities will have between 300,000 and 400,000. Just to make sure, according to the number of US cities with a population between 350, not between 300, but 350. That's what it didn't make sense. Okay. Is approximately. Okay. Round to the nearest whole number as needed. Fine. Okay. So we have 350. We have 400,000. I have to turn that off.
I thought it was 500,000.
Say that again.
Is it 500,000?
I think the first one, let's look again. I think the first one says between 350. Oh, yes. Between 350 and 500,000. Yes. Perfect. So we have, so the 350 to 500. So let's see what we get when n equals this with s equals 500,000. So the relationship was determined from this initial information, 52, 350, and I determined k. Now, once I have k, this is the relationship between the number of cities with a population greater than 350 and the population, and S. So now I have 500,000. So I want to determine and see what the number of cities for 500,000 is. So I will determine by dividing this by 500,000. So I got that n equals 36.4. What did you enter? So that was for 500,000. And they're asking us between 350,000 and 500,000. Well, for 350,000, we do have 52. For 500,000, we have 36.4. So what will be the estimate now of the number of cities with a population between 350, which are 52, and 500,000, which is 36, is the 52 minus 36.4. And they're asking us to round this. I don't need a calculator. So 52 minus 36 is approximately 16. It's not. It's 15.6. So that's what we have to enter. Because they want us to round up, what do they say? Round to the nearest whole number as needed. Now let's look at the other one. So they want with the population between 250 and 650. Let's check that one. So we repeat this statement, the steps for, so 18,200,000, and we divide by the other two numbers. And again, 250, 650. So we will divide by 250. We will divide the other, so 18,200,000, and we divide it by 650. When we divide, we will see what the difference is. So let's do that. Let me know if you can still see if something needs to be adjusted anytime. So I'll divide this. My calculator is here. 18,200,000. Let me make sure I put enough zeros. 3, yes. And divide this by 250. Good. And I got here 72.8. Let's see what we get here. I just changed this into 6. And I got 28. So now the difference between these two will be 72.8 minus 28. And what do I get? 0.8 and 4 and 2 from 6. I got 72.8 for this. And I got to 28 for this. Okay, what did you get? What was it? Ah, why did they, what do they say? Where is my button here? 250 and 650. They say approximately 34. No, I'm not getting 34. What did you get? I'm getting 44. So according to this, I think it says that it's the answer is 34, but I'm getting 44. I'm not getting 34.
That might not be, maybe it's not checked. You know, you can check the answer, maybe I might have sent the email before the answer was already checked.